Section 1 Intro. I don't know why I keep reading this out loud. Just nonsense of mine. Yo, what up guys, Alex here. So today I'm breaking down my common approach to testing an application. It doesn't really matter if it's web or mobile, although we'll keep our focus on the web for now. The strategy stays the same. And since my background during the last few years is mostly backend testing, this whole perspective is coming from the backend first mindset. So my approach is kind of mix of a data-driven and event-driven testing. I'll explain why in a second. But first things first, let's start from the day one. Let's say you just got landed in a new project. What's the first thing you got to do with it? No, not playing with the UI, not writing TypeScript interfaces, not solving algorithmic puzzles to prove what as smart as you are. No, none of that BS. You need clarity on these 3 points. Number 1, what entities exist in the system? Number 2, what roles and permissions are tied to those entities? And number 3, what are the relationships between those entities? How do they interact? What is the hierarchy? Without this, you're going nowhere. So please stop asking me dumb interview questions like, can you reverse a linked list, and start asking, how can I analyze system architecture? Because that is what actually matters.
Section 2 Example Project Cybersecurity SaaS.
So let me give you a real example. I was in a SaaS B2B project in the cybersecurity domain once. Here's how it was structured. Let's go to the Lucy chart.
Okay, so let's dive into this a little bit. So entity number 1, we got the company. So let me just drop the shape right here, make it a little bit bigger because it's gonna include other entities. So this is the company. I should have added here. Let me add it here, company. Okay, right. So company can include other companies like subsidiaries or internal departments. So it can be nested endlessly like a Russian doll, like the Matryoshka, I guess it's called. So we got, let's say, just to display that, say we got sub company 1, 2. I think you get the point, right? So technically sub-companies and companies are the same entities. It's just that they, can be nested within one another, like a fractal, like a never-ending fractal. So let me push it right here a little bit. So what do we have next? So the next entity we got is the administrator. So the admin. The admin belongs to a specific company like this one and has access, to everything inside that company and anything below, in the hierarchy. What I mean by that is an admin can, let's say, modify and use any component within the master company or within the main company and do so within the sub company, and the sub company of sub company, something like that, if we put it like this. Okay, so the admin can, let's say, functions, add, edit, remove users. Then, the admin can manage subscriptions. Of course, the admin can create new companies such as these. So basically, he has got, the God mode. But it's important to remember that he can do that only within the master company. So, say we got another, company 2 or something like that, or, a master company 2. So this admin won't be able to, somehow influence the processes within that company because it's just a separate entity technically. So let's get back here. It's important to know that the admin and the company creation happen through the sign-up process via the web UI. So let's point that out. So let's point that out too. So we got a sign up process. So we got no DB hacks, no backend shortcuts. Everything is transparent and user facing. So this process consists of several steps. Company info step. Then we got the admin info, user info. Of course, we got we have the billing selection or page. You get the point. So all of these kind of in the end it leads to a creation of this entity. Within that entity, you already have the admin. So that's a process, and that's a somewhat of an end-to-end test case, if you ask me. So let's get back to this company right now. Let's continue with the entities. So the next entity we got is financial manager, right? So this fella right here handles subscriptions for the company, but only for the main company, not the subsidiaries. So they got their own, accountants or, fin managers as we call it. So, you name it. Another entity within the company or, let's say multiple entities are cybersec specialists, cybersecurity specialists. Say we have, there can be lots and lots of these guys because they've had like, specific departments which would consist only of the cybersecurity specialists. Okay, so, and then there is more. So there's like customer support, there's like developers, managers, like you name it, because, there can be lots and lots of people inside the company. What I'm trying to point out here is that this is like the main entity within which all other like sub-entities exist. And these sub-entities all have their, rights and permissions, or roles and permissions within the system. So I'm trying to display like the relationships between these, entities, hierarchy-wise, so to speak. So we got like the customer, supporter 1, 2, and so on. I mean, you get the point. Not gonna stop here too much. So like, what really matters here is that all of these entities are like tied to, the higher entities on the hierarchy, such as company, right? They're part like of the bigger and broader entity, which is an organization in this case. So they like possess different roles within the system, which I've just said, right? So, which in itself contains permission to access, various system components. So the company can, have, and it also has like system, the components such as, billing, or for example, admin-wise, it's like editing the users, like a users page or users list. So, or, financial manager can access the subscriptions page, while the tech support, cannot, and the cybersec also, right? So you get the point. So yeah, and these entities got like very clear relationship with each other, which lets them be involved in common scenarios, right? So, such as, the admin can update credentials of a cybersecurity specialist, for example. So that's like a part of my approach, like, let's call it, entity mapping or whatever the hell. Right, so once we figured that out, we need to figure out the system components, as I've just said, and, the step number 1 here should be, from my experience at least, should always be authentication. So, how do I access this thing right here? So are we using bearer tokens? Like, how do we log in? Is it like bearer tokens? Is it MFA with an OTP, or is it like an auth? So we gotta figure out the authentication method. Let's say an auth method right here. These are mostly the questions right here. So this is your entry point to the whole system. So without knowing like how login works, you cannot test shit. Step number 2 is gonna be the data sources. It's called the data sources. I'll explain a little bit. The data sources. So every component, like a dashboard, for example, is filled with data. We need to figure out like where does these data come from? So which services are behind that? How are they connected? What permissions are needed to interact with them? So UI, once again, UI is just a shiny wrapper. If the data is not, displayed properly, it means that we have some backend issues most of the time, which like in its own terms means that the API doesn't return us expected data or the expected outcomes. So the next step is probably one of the most important. I'm gonna call it API or APIs even. Like every user action triggers something. And usually this action means an API call beneath the surface, right? So like behind the scenes, under the hood, whatever you want to call that. So like, changing the user profile, like editing the user, updating the company data, such as, for example, on the sign-up process. All these invokes different endpoints. So you need to figure out, like find the APIs which are being used within the system, get access to their schemas and understand their authentication. So whether it's like tokens, keys, API keys, like cookies, or whatever the hell, like OTPs, you name it. And you want to get your hands on things like, probably Swagger docs or Postman collections, like anything else like developers are using internally. Because mostly this is where the real logic lives. Like, not in your like pixel perfect forms and buttons.
Section 3. Building your testing foundation.
So now that we have figured out the entities and we've created our test org and accounts, that's just the first part. Next step, you need to understand what services and components are used within the app. Whether they're native or third parties, like integrations, it doesn't really matter. You need access to those things. And let's break it down a little bit, okay?
Section 4. Another company testing approach example.
So let's try this approach for another project that I've had, this time in the clean energy domain. Let's go back to the Lucid chart.
So let's start with the potential or like existing entry points. What I mean by that, these are the key points where the users are generated, where they come from, where our clients start the interaction process with the company. So the first is gonna be like web UI enrollment. That's the first and foremost. This is the landing page or like a website where user can where user can navigate and undergo some specific steps and at the end of the day subscribe to a service. The next can be like, I call this hot sales. This is pretty old school now. These are the IRL sales where people either walk around the streets and propose stuff or go to some offices or call other people. So yeah, this is old school, but still has a place to exist. The next entry point can be the referrals. That's pretty obvious too. One person recommends a friend or our service to a friend. Friend goes to a specific page, undergoes some other enrollment, and just becomes the client of our company, bringing us money in the end. So yeah, pretty simple yet effective. And these basically what I'm trying to say here is I'm trying to map out some potential entry points so we can bounce off of that. So the next thing, let's take one of these entry points, for example, the web enrollment UI, right? So this is a process in itself. So it consists of several steps. So let's say step 1 is providing zip code for location validation, because the system is branched off for specific states. So it's got distinct logic for a specific state, because in every state has different energy provider. So that's why we need to explicitly modify that logic per state. But nonetheless, so user usually provides the zip code, then providing contact info. Then user provides the contact information such as first name, last name, email, and mobile phone. There's a bunch of other stuff happening right there, but I'm not gonna turn your attention to that for now. And then the next step is address info. This is pretty important because user can have billing and shipping addresses, with address for which the user pays and address where user actually lives. So this is another step right here, and the last step here is gonna be utility step. The utility account number is basically the number which lets you use the service of the clean energy provider in this case. So that's how it goes. Each user has a utility account number which is unique per utility, or at least it should be unique per utility, which is understandable. For example, if you have one house and 2 flats, or 2 apartments, right? Or 3 condos or whatever. So each of those condos, each of those property objects has its own utility account number, which is unique. Right, so this is the enrollment, this is what the user sees, right? And then the last step probably is final step, showing our user the success page, which is you have successfully enrolled, welcome to the system, we're happy to have you as our customer. Okay, so this is this is the process, and this is what the user sees. But now let's dive a little bit deeper, and I'm gonna map out because it's gonna take a lot of time if I'm gonna do this fully. So just for the demonstration purposes, I'm gonna show you what's going on behind the scenes, right? So when the user, at the point where the user provides the zip code, the under the hood process begins. And these, we have a lot of systems which are basically third-party integrations, which have their own APIs and which collect data from every single step that a user completes. So let me just, probably kind of draw the arrows all tied to this box so that it's more visually understandable. So we have a tool, I'm not gonna name the exact, tools, just, for security purposes, but for the demonstration purposes and for my approach to the testing of such projects, or mapping such projects, this would go like this, right? So there is some cart management system which collects, like, creates the ID of the cart, of the user's order, and of the user, and it collects specific user data right here. So once user has completed, this step or these 3 steps, or like all of these steps, this data goes here, and it has the downstream data flow, which consists of several other, let's say, steps, right? Each of these steps involves a specific system. So then we have like user profile and subscription account management system. Let me make this a little bit larger here. So the data flows there. It creates the user profile and related entities. So in case of, the user is just a single entity. In case of with the card, it's also a single entity. But here, for example, within this system, it has like several entities. So it's kind of divided into several entities, right? So let me name it something like this. So first entity is kind of, the individual profile, which is the main entity within the system, which has the main user data, kind of reflecting the, the persona profile or the person's profile. And then it's got like related entities, right? It's got like the retail subscription, which has some address info taken into consideration right there, some plan codes and whatever. And then it's got the utility account also, which has mostly it has the data collected from the utility step, unique utility account number. And if a user has lots of those, they're going to be like tied to this master entity, which is the individual profile. So that's another thing. The next thing which happens is the data flows further and further. And this system I can name because it's pretty mainstream and many companies use it. And it's called the Salesforce, specifically sales domain. So once again, just like here and here, user profile is created within the Salesforce. The only thing is called differently, right? So, and it also has like a master entity, which is called opportunity, but you can customize it to suit your company's needs. Let me just quickly name it like opportunity. And it also has a couple of related entities to this opportunity, such as the contact, which like obviously contains the contact info of the user. And it also has the utility, which is tied based on the information provided. And this differs, from state to state. And the process goes on and on. Like then we got like marketing systems, some data aggregator systems, which are used by different departments within the company. So this is like, and this is also like, this is the surface level. And this is the first level, like under the hood. And then there is like a deeper level under the hood. So like, as you probably, like if you've been following me along, so I've mentioned that there is like a data flow process right here, which exists between the systems, like data sync and then entities creation. But what's going on like behind the scenes, right? So if we dig even deeper, we got, some messages queues and some, let's say, Lambda functions. All of this is called the AWS Web Services. And these services, they kind of manage the data sync, the, let's say, the actual data parsing, data transformation, to some specific formats behind these, third-party integrations. So if I was to, map it out somehow, I would probably, add some more components between these connections. Name it, for example, AWS Event Bridge, right? Event Bridge, for example, which kind of routes, catches and routes the events with the specific data to the specific, let's say, what do we have? This circle. To specific AWS Lambda function, which later on, like in its own terms, like transfers the data to the specific system because it's got a built-in integration. Let's not forget about the SQS queues, which manage, the actual queuing of the messages, and so on and so forth. So, when another sync happens, there's some other AWS Event Bridge instance involved, and there's like another AWS Lambda involved. So, you get the point. So this is like the deepest level. Well, not the deepest, but, the deepest which we are suitable or like, which is like automation worthy. And the deepest level, of course, is that we have the databases which are being used and triggered, the data transfers. The data like usually transfers to the databases, during specific steps throughout this flow, right? So it can be at the very beginning right here. It can be, at the some entities creation within the third-party applications. So this may be the same service for the database. It's just that the different data in different tables are updated throughout this flow. Okay, so I think you get the point, right? So once we have mapped this, all of it out, we can try and map out and test design the possible like end-to-end test cases or integration test cases if we want to check some specific part of the flow, not the whole flow. So this is like a reality tree or status diagram change or like flowchart, whatever. So I think you get my point. You gotta map shit out before you wanna create the actual test cases. So it's like visually readable, and you don't have to abstract too much, and you don't have to fry your brain that much, right? So the best way to do it is in conjunction with other colleagues, with other departments, probably with other leads, like a dev lead or tech lead, probably some other people involved with this, other stakeholders. And once you have that, you gotta also figure out, let's say, the scope of testing, which includes the test data set 1, for example. That'd be like for the Washington state, right? So if we have like the test set for the Washington state, the web enrollment is gonna look like, it's gonna have like specific amount of steps, or it's gonna need some specific data, specific test data. The next we got, let me call this like test data set 2, let's say Illinois state, right? So it's gonna have its own logic, which is also gonna be distinct. So probably in Illinois, for example, you're not gonna need, let's say, the utility step because it's gonna be embedded into the address info step, or you're gonna need some additional steps such as letter of agreement or something like that, or terms and conditions. So you get the point, right? So we can have like multiple and like close to infinite amount of test data sets, but in this case, in case of this project, it's kind of only the actual amount of states limits that. But that's not the limit if you take look at it like long term, right? So MA, for example, I think you get the point, right? So like this is my approach to to testing like a project and seeing it as a whole. I need to map shit out. I need to get accesses to the services which I'm mapping out. I need to understand the relationships between the entities, between the subsystems, or between the third-party applications. And after I'm done with all that, I can actually, begin my test design for later automation. So pretty working strategic approach, which is basically event-driven and data-driven. So yeah, that's about it.
Section 5. Your baseline checklist.
So once you gather this info, your test foundation should look something like this. First, list of entities. Second, their hierarchy. Third, relationships and interactions between those entities. The next, API list, both native and third-party apps, like integrations, apps, whatever you call that. The next thing is access to DBs and services. Could be SQL, Postgres, Mongo, Firebase, you name it. Could be a combination of those even. A technological zoo, so to speak. The next, if you're dealing with payments, get a test card credentials for your lower environments. And don't even think about testing this in production. So, have you noticed something? That UI is not even on the list. Why? Because UI for me is just a wrapper. Yes, we'll write UI automation. And yes, we'll cover critical flows like end-to-end. This is a must, this is understandable. But the real game is in the data. The real game is in the data and its interactions. Data flows, data relations, correspondences from one parameter to another, like all that, behind the scenes logic. So the deeper you go, the more scalable and stable your test coverage becomes.
Section 6. Event-driven versus data-driven testing.
Okay, so when does the event-driven testing come into play? Simple. Every action in your system is an event, and you should treat it as such. For example, user clicks sign up, triggers an entity creation or generation or whatever. Admin updates a user. This triggers a put API call, for example. The next is cybersecurity analyst flags a threat. It triggers a notification. It also triggers a database entry. Or a Salesforce agent changes user profile data, which triggers a subflow not visible to the surface, like at the surface for the naked eye. Or, on the contrary, triggers a specific email campaign which sends a condition-based email. Every single thing is an event. And your job is to identify and map those events, and also track what they trigger behind the scenes. Now let's flip the coin. Where's the data-driven part here? Well, events don't just happen in a vacuum, you know? So they're triggered using specific data sets. And, you know, if you're changing the data, you're changing the result. That's obvious. So, for example, signing up with a US phone number versus, you know, a non-supported country phone number. Then you got creating a user with missing fields deliberately. And, you know, of course, like testing edge case values. Our favorite QA question, what happens if I do this? So here's your formula. Action equals input equals data equals event equals output equals result. A result which can be measured, which can be validated. And, you know, most likely then later automated. So that's it. I combine both approaches because, you know, that's the only way to make testing reflect reality, or like real user behavior.
Section 7. Build the event tree reality map.
And from here on, I build what I call the reality tree. Or, you know, some people call it like status change diagrams or whatever. You might also call it a transition map or a flowchart, or whatever buzzword your team uses. But the point is, it's a structured map of events, triggering data, outcomes, and, you know, next possible events. So this becomes your source of truth. And guess what? From that tree you can generate like Gherkin scenarios, you know, given, when, then, and so on. You can design manual test cases with ease. You can choose later on, you can choose which of these manual cases are gonna be like automation worthy. You can create regression suite. And of course you can add like visual coverage charts if you wanna, if you need to. You know, or if you're into that, of course. The point is, you do not write random tests. You pinpoint and map out what actually matters. And only then you write tests, you know, based on the events and data combos that actually, you know, move the app forward, that actually get tested, you know? Jesus, so obvious. So remember this, your main task as a QA, and it always been such, and it will always and forever stay as such. So your main and only task, to keep that in mind, is to emulate real user behavior. Whether it's an internal user or whether it's an external customer, you know, each system has external end customers, we call them such, like, you know, the clients which actually bring us money. But systems also have the internal users, you know, such as operators, like data managers, like let's say if we take the Salesforce, we got the Salesforce operators which you know, tend to work with the client's profiles, like changing pricing plans out there or changing the contact data within the client's profiles. So this also can happen. You gotta think like from all of these, you know, kind of perspectives, like end users perspectives at once, or not at once, at least one by one, but you gotta map that out at first. Because without it, it's just gonna be like, you know, forever exploratory testing and forever black box testing, which is bullshit. You know, you gotta have some, you know, input data about the system you're working with. That's a must. And your colleagues that have been on this project before you, they most surely know that. So please do not hesitate and speak to them. I have never hesitated to talk to anybody if I didn't know something, if I had to figure out something. And the same thing I'm preaching right here. It doesn't, you know, it's nothing. It's just nothing. I know that, you know, lots of people in the IT, they're very like closed in their own boxes. They don't want to talk much. They don't want to like be around people much. You know, I am just like you in this case. You know, I tend to live a hermit life, but it's not the case right now. So my main point is that you got to talk to people on the project if you want to know more about the damn thing. You know, that's just pretty obvious to me, at least to me. Okay, so then you gotta define the test cases, you know, select the most critical ones and automate those, you know, so that you keep your hand on the pulse of things. And please stop the goddamn rush. Just because some agile methodologies said so that you gotta release every 1 week or 2 weeks to make some management happy. Well, you know, this bullshit, because in reality, you just gotta release something that works and brings money to the table. That's it. You don't have to keep in this hype loop, because it burns you out just for nothing. And if you look at it long enough and precisely enough, you're gonna find out that it's just emptiness. It's just nothing. You know, this never-ending loop is just nothing. And sometimes it even, you know, brings more negativity than positivity to the process. Yeah, you can use the agile methodology, be in a 2 week or 1 week or 3 week sprint, but would it actually matter if you're releasing bullshit? or if you're like rushing that much that that you get people burned out. Would that matter? I don't know. To me, it wouldn't. Maybe you have other opinions on that. That's your choice. So once again, stop the rush. As Gabe Newell once said, while being asked about the Half-Life 3, whether it's ever going to be released or not, he said like, good things, they take time. So, the system, once you fucked up and fatigued, that's for sure, don't let it. Listen to that inner voice. Listen to that inner voice. That is the real you. So,
Section 8. Final message.
oh, and one last thing before I go. I noticed that, most companies don't even ask the right questions. So they're like out there throwing TypeScript inheritance trivia at me, as if it's gonna protect their prod system from going down at 2 a.m. or whatever. Let me say it loud and clear. Users are not dumb. They bring you money. Is it too hard to understand, and have some goddamn respect for the people? Because your parasitic mindset is not gonna get you anywhere. So if your app is confusing or broken, they'll bounce. No loyalty, no second chances, they'll just leave. Just gone. And on top of that, if you frustrated them enough, they'll take, a huge dump on you on the social media. So, boy oh boy, you're scared of that, aren't you? So, stop building stuff just to get it done, okay? And stop hiring QA people just to click buttons or solve stupid code trivia nonsense. That's it for me for today. As usual, see you in the next sprint. Alex, over and out.